Determine the components along the coordinate axis of the position vectors for the following point. Okay, let us begin. To begin with, what we'll do, we'll consider an origin O of some coordinate system with respect to which we are measuring point P, Q, R, and S. Let O be the origin. Let O be the origin. Now, let us consider OP to be the position vector of point P. So here, let's say we have the point P lying on the first quadrant because both x and the y coordinates are positive. So we have point P corresponding to the points coordinate values 3, 2. So here we have defined OP as the vector going from point O to P, and this is going to be the position vector of point P. Now what we'll do, we'll try to express vector OP in terms of the unit vector I cap and j cap. Now by definition, I cap is the unit vector along x-axis and j cap is the unit vector along y-axis. So what we'll do, we'll drop a perpendicular from point P on both the x-axis and the y-axis. Let's say it meets the x-axis at point M and the y-axis at point N. That means OP vector is going to be equals to OM vector added to MP vector. Now OM vector can be also expressed as magnitude of vector OM multiplied with I cap added to magnitude of vector MP multiplied with j cap. Now what is the magnitude of OM? That's nothing but the x coordinate of point P that corresponds to 3 times I cap. That will be added to the component of the y coordinate of point P, so that's 2 units, so we have 2 times j cap. So here we have expressed OP vector in terms of the unit vector as 3 times I cap plus 2 times j cap. Now our goal is to define the components of OP along the x-axis, the components of OP along the y-axis. We need to define the components of the vector OP along x-axis and components of vector OP along y-axis as well. So components of OP along x-axis, that's simply going to be positive 3. Components of OP along y-axis, that's the magnitude value, that will going to be 2 units. Then components of OP vector along x-axis, that's given by 3 I cap, and components of OP vector along y-axis, that's going to be equals to 2 j cap. So now that you have understood how to define the components of the vector OP along x and y-axis, now we can easily solve 2, 3, and 4. Let's do that. Coming to the point Q, it has got the coordinates -5, 1. Now we can define the position vector of Q as OQ vector as -5 I cap plus j cap. Now our goal will be to define the component of OQ along x-axis. That means we are only considering the magnitude of the vector OQ along the x-axis. So that's going to be +5, and the magnitude of vector OQ along the y-axis, so this is going to be equals to 1 unit. However, if we want to find out the component along the x-axis of the vector OQ, so that's going to be given by -5 I cap, and component of vector OQ along the y-axis, that's going to be j cap. Okay, coming to the third one. The third one, we have the point R. So R has the coordinates -11, -9, which means that we can express the position vector of point R as OR vector given by -11 I cap minus 9 j cap. Now what is OR? What is OR along the x-axis? So that's going to be 11. We have to be very careful here. We are only considering the magnitude value here. But the component of OR vector along the x-axis, so that will be equals to -11 I cap. So this tells us that it's going to go 11 units along the negative x-axis. Then we have the component of OR along y-axis, so that's simply going to be +9, and the component of OR vector along the y-axis, so that's going to be -9 j cap. And coming to the final point, we have the point S with coordinates 4, -3. So here we can express the position vector point S as OS vector given by 4 times I cap minus 3 j cap. Now that means OS along x, the component of OS along x-axis is going to be 4 units, but the components of OS vector along the x-axis, that's going to be 4 I cap. Then component of OS along y is going to be +3. Components of OS vector along y-axis, so that's going to be -3 j